Hello and welcome to the second video, and today we are going to continue studying chapter 1 of Ganita Prakash, which is a textbook for maths. Alright, this is for 8th standard. This is the part 1 textbook, a square and a cube. And today we're going to continue from this point, which is on page number 3. Alright. So this is square numbers, and we're going to actually now start looking at what square numbers are and what are the properties of the square numbers. So to begin, just let's see what square numbers are, right? Let's say this is a square number. Why is it called a square number? Or rather, when is it called a square number? When you can express it as a multiplication of some number with itself, right? This is a very simple way of representing it. So let's say I take the number 4, right? I can write 4 as 2 into 2. So the multiplication of 2 with itself, okay? So whenever you have a number which can be expressed as a product of one number with itself, right? So that number is known as is called a square or a square number, right? And this number here, 2, this is called its root. So this is a square root. Now let's go back to our textbook. The first thing that they're trying to tell us is trying to explain what is the reason that we call it a square, okay? So just when you think of a square, what do you think of a square, right? It's a four-sided figure, right, which has whatever, like the length, let's say this is 3 centimeters. It will have equal sides. All 4 sides will be equal. That's a square, right? And this is 90 degrees. All 4 inside angles. So that's a square. Now, if we divide it into unit squares, right? Unit square, what is a unit square? It is a square which has the sides of 1. Then I'll have to divide it into this many squares, right? So there'll be 3 over here, 3 over here, 3 over here, 3 over here. So this is how much? This becomes 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. Alright. This 9 can also be represented as 3 into 3. Okay. And honestly, this is the only reason that you can just think of why it is called square, why the word square is being used. Alright. So this is just to for you to know that it can be a way of thinking about it, right? In the terms of geometry. In general, if you want to write, if you write n into n, if you multiply n by n, this becomes n square. Okay, and this 2 over here, it just means that you've multiplied n with itself 2 times. Okay. If you write it as 3, which is cube, which we'll we'll study about it later on, then it would be n into n into n, and n can be any figure, like n can be any number, right? This is 3 times, so we've written 3 over here. Okay, so this is n square. Now we'll just move on to some properties. All right. First, let's figure out what is a perfect square. Let's say I multiply 4 with 4. Okay, if I multiply 4 with 4 and I get 16. 16 is a square number and 4 is its square root, right? Just the way that we did it here. So now if you see, 4 is a natural number, right? What is a natural number again? It starts with 1 and then all the integers after 1. So 1, 2, 3, 4, 5. These are natural numbers, right? So the square root of 16 is a natural number. When that happens, this is called a perfect square. Right? Because I could just multiply, let's say 4.5, okay, into 4.5. Okay, so what this answer will be? 20.25. Now this number is also a square and the square root of this number is 4.5, right? But this 4.5 is not a natural number and therefore 20.25 is not a perfect square. It's an imperfect square. So that's the first thing. If the square root of a number is a natural number, then that number is known as a perfect square. Okay. If you have any questions or if you think that I'm going too fast, just let me know in the comments. So from the next video, I can work on that and, either go slow or just explain more. Next is this table where we're just asked to write all these first 30 squares. And using that, then we will look at the properties, right? So I'll just pause the video and I'll fill this table and then I'll move ahead after that. Okay, so I've just written all of these. So let's just quickly go through them, right? So 1 square is 1, 2 square is 4. 2 square means 2 into 2. So 2 into 2 is 4, 3 into 3 is 9, 4 into 4 is 16, right? Just like that then, 5 square is 25, 6 square is 36, 7 square is 49, 8 square is 64, 9 square is 81, 10 square is 100. And then similarly over here also 121, 144, 169, 196, 225, 256, 289, 324, 361, 400, 441, 484, 529, 576, 625, 676, 729, 784, 841 and 900. So the reason that we've written this is to just take a look at the patterns that come up. Okay. So what are the patterns that come up? The first thing that we see, right? The first thing is that even that when you're multiplying two numbers or when you're multiplying two numbers, the first thing, the units digit is what? You multiply the units digit of the two, right? So let's say if I multiply 25 with 26, okay? The first thing is what? What is step 1? 6 into 5, right? So that is 30. And then 6 2s are 12. Then you put a cross over here and then you multiply this and you get this, right? So what is happening over here? When you do this, what is happening? The units digit here is a multiplication of the two unit digits and the unit digit of that, right? So what I'm trying to say is that when you multiply these two, whatever number you got, if you multiply 5 into 6, you get 30. The unit digit of this number will be the unit digit of the answer. Okay. So which means that if it is 25 into 25, so then you have the unit digit will be 5 into 5, which means 25. So it will become 5. Okay. That also means that no matter what number comes before 5, as long as the units digit is 5, the square will always have the units digit 5, right? So then that means that if the unit digit is 2, the answer will always have a unit digit of 4. And you can see that here. So if it's 2 square, it's 4. If it's 12 square, it's 144. If it's 22 square, it's 484. So all unit digits are 4. Okay. Same thing with 3. 3 3s are 9. 13 13s are 169 and 23 into 23 is 529. The units digit is same. Okay, which means that if you know the units digit of of whatever number, you know the units digit of the square, right? It will always be this. Whenever you have a number, like let's say for example 7, right? Even if you have say 437 square, okay, whatever the answer might be, the units digit will be 9. It will end in 9, right? Because 7 square ends in 9. That is why no matter, even if like let's say you make it 5000, even then the units digit will still be 9. And what does that mean? What does that show us? It shows us that the unit places or the unit digits of square numbers can only be these ones, right? It can only be these. It can't be anything else. You can't have a unit digit of 2 for a perfect square because none of these have 2 at the end. So what does that mean? Which digits cannot be in the units digit of a perfect square? What are those? 2, 3, 7 and 8. Right? If you see again over here, none of these end in 2 or 3 or 7 or 8. Right? So a perfect square cannot end with these numbers, right? Which means that if you have a number and it ends with these, you can directly say that it is not a perfect square. You don't need to do any other further calculation. If it ends with these numbers, it is not a perfect square. Okay. This, however, does not mean that if it is ending with other numbers, so let's say we have the other numbers are 0, 1, 4, 5, 6 and 9, right? If the number is ending with this, it's not necessary that it's a square, okay? So numbers ending with these could be squares, or rather perfect squares. It's just a good thing, right? Let's see an example. You know that 25 is a perfect square. It ends with 5. It is 5 square, right? But 35, 45, 55, these are not perfect squares, right? So all we are saying that if they end with this, they could be a square. But if they end with these, they cannot be a square, right? So just try to understand that. We'll stop here in this video and then we'll work on the next properties in the next one. I just want to keep all of these small bite-sized videos. Okay.